Excuse me. Okay. So, first of all, this elementary matrix has what effect on the identity matrix? Well, it looks like we've added double the third row to the second in order to get this. Verify that that's so. And of course, this matrix is the one that we get from the identity matrix if we double the third row and add to the second. So our inverse matrix is this. Now, this is the double the third row, add to the second elementary matrix. How would we undo that? What would we do to this matrix to get back to the identity? Well, it should be pretty clear that we subtract twice the third row from the second. So to get this matrix, we took this one and added twice the third row to the second. If we want to go backwards, we're going to subtract twice the third row from the second. And the matrix that does that is this one. Okay, we take that operation, subtract twice the third row from the second, apply it to the identity, and this is what we get. Remember that an elementary matrix is one that does a single row operation, either switch two rows, multiply a row by a number, or add a multiple of one row to another. Okay, so and the elementary matrix that we get is the matrix we get if we could take the identity matrix and perform that row operation on the identity. Okay, well, that you should be familiar with at this point. If not, you need to do a little reviewing. Okay, now the next elementary matrix we use is, well, you see it, I'm not going to read it to you. And we multiply it and we get this. Now, what row operation would you use to go from here to here? Well, you would multiply the first row by 3. Everything else stays the same. First row is multiplied by 3. Well, if you multiply the first row of an identity matrix by 3, this is exactly what you get. Now, how would you undo it? If you wanted to go from here to here, what would the operation be? You should stop and think before you listen to my answer. But the only difference between this matrix and this matrix is that this row is 1/3 of this. So the inverse of our elementary matrix will be the one that takes 1/3 of the first row, and that would be this matrix. Okay? Now, what is this? Well, how do you get from here to here? Okay? What operation would you do to get from here to here? Well, and you should stop and think about it. You should see it before you look at the matrix. So I'm going to say it, but hopefully you've already thought about it and identified it. We've added twice the second row to the first. So we add twice the second row to the first. Here's our new first row. What elementary matrix do we use? We use the one that adds the second row of the identity to the first, which will give us a 2 here. So if we multiply this by this, we accomplish the result. How would we undo this? Well, we would subtract twice the second row from the first, or add -2 times the second row to the first. And here's the matrix that does that. And of course, this is easily obtained by adding -2 times the second row of the identity matrix to the first. Okay, this matrix here, this matrix switches, I'm sorry, doesn't switch. It adds, well, we see what it does. Now, let's go over here. How do we get from here to here? Let's think about what's actually done. Okay, well, we see we got a -3 and a 2 here. We got a 3 and a 2 here. We got a couple of zeros here. It looks like we subtracted the first row from the third. Okay, how do we do that? Well, it's -1 times the first row plus the third, and that'll go into the third row. If we do that to the identity, add -1 times the first row of the identity matrix to the third, this is the matrix we get. So multiplying this matrix by this matrix gives us this. How would we undo that operation? We would add the first row to the third, and we'd be back here. And here we have the matrix that we get if we add the first row of the identity to the third. Okay, then we have this final matrix, which actually accomplishes 2 things. It multiplies the second row by 2, and it also adds the third row. Again, that should have been split into 2 elementary matrices, but among other things, I didn't have room, and we didn't want to spend too much time talking about these details. So if you do the two matrices, then you would actually get two elementary matrices that would multiply out to this matrix. Again, you can see what the determinants of all these matrices are. That's very straightforward. So, why would we do this? Well, so we understand, among other things, the way I generate problems on your test is I usually start with the identity matrix or some other simple echelon form of a matrix, completely reduced echelon form with ones and zeros and ones in the right place and so forth. And then I just do some random row operations to build up a matrix, and that matrix is the basis for the problem that I ask. Okay? And one question I might ask is, okay, how would we reduce this matrix back to the identity? Well, let's think about that. How would we reduce this matrix to the identity? Is there anything here? Are there matrices that would help us do that? Okay, well, we're going to confront that in the next video.